Welcome everybody to my talk. My name is Ionut Balosin, and today we will talk about techniques for a faster JVM startup. The agenda is quite packed in the sense that I'll try to cover a few such techniques. You have here on this slide the app Dynamic CDS from HotSpot. I will briefly explain and show you how a similar feature works in a different JVM implementation, which is OpenJ9. It's called Shared Class Cache. And at the end, last but not least, AOT with Graal VM native image. First of all, before to start, few words about myself. I work for Raiffeisen Bank International in Vienna. I'm software architect, but besides this, I do a lot of other things. Mainly, in particular, I do training. So if you want training on the topics listed on this slide, feel free to get in touch with me. I also have a blog. I go to conferences to speak and so on. Okay, but maybe this is a bit less important for today's topic. Let's see, before really jumping into the topic, why we should really care about the startup. For which type of application startup matters? Because you might argue, yes, of course, it's not everywhere where I should be worried about startup. And you are perfectly right. Because basically startup matters in essence for short-lived applications. This is a particular case, serverless applications, if you are using cloud, and more of us are using cloud. For function as a service, if you are using AWS, they are the so-called lambdas. And this kind of application, basically you use an JDK or an SDK, sorry, provided by the cloud provider. And with that SDK, you create your own package, your own deployment package, and it runs into the cloud, and basically you don't care at all. So it runs it once, it does the job, and it stops. And this is why, for example, when you have especially real-time applications or things where you want latency to be minimum, of course the start time matters in such cases, because you don't want actually to wait a lot until the JVM starts. The benefits, of course, if you think about cloud, are cost savings, because you want things to start quicker and to do the job and to terminate. Also, during development cycles, you want quick feedback. So, for example, you deploy something, you want to see how it reacts, and then continue. All in all, it's basically about minimizing actually called startup for called start scenarios. If you look, there are basically three categories. You have cold startup, warm startup, and hot startup. Cold startup, and this is my main focus for today, refers while the JVM starts from scratch until the moment it's functional. So it means it receives first request. Warming the JVM basically is to avoid just-in-time compilation, to bypass, for example, the interpreter, to reach a steady state. And hot startup, it's basically you are in the steady state and then you resume execution. So all in all, my main focus would be for cold startup or on cold startup. And for this, I'll share with you a few techniques. Of course, there are more than this, the things that I'll discuss today. I'll try to aggregate on this slide all of them. Nevertheless, of course, each deserves its own presentation, because there are quite a lot of things to discuss each of these in details. So my focus for today will be the top three. Nevertheless, today I saw in the agenda of the conference there is a talk specifically on OpenJDK crack, coordinated research checkpoint. So if you like this topic, yeah, you might also attend the other presentation. Okay, so let's start with the first one, which is App Dynamic CDS in HotSpot. Why HotSpot? It's of course the most used JVM implementation, and I think this feature, it's not so used as it should be, or it's not only it's used, but it's not well known across the community. So let's start with the beginning to understand a bit the context. What is CDS? Basically, CDS, the idea is pretty simple. The CDS refers to some cache process metadata that are basically packed and dumped on a disk. It's like an archive. It's like an archive which basically is created after the classes are loaded, and those classes on a subsequent JVM runs it's more efficient basically to read the classes from that archive instead of going through the normal process of, for example, loading the classes, checking the bytecode, and so on and so on. So the rationale is that loading an archive which contains pre-processed metadata, it's much faster than starting from scratch. The feature itself, it's in Sun JDK 1.5, but the constraint, or not the constraint, the thing was that it works only with system classes. For example, this archive, the CDS archive, contains only core classes which are used basically by the most applications. In a nutshell, for example, there are classes from Java Util, Java Leg, Java IO, and so on. And these classes are loaded by the Bootstrap class loader. For example, in JDK 17, there are around 1,300 such classes, as you can see here. And these are basically dumped, they are included in the archive. Since JDK 12, this archive is implicitly created when you install the JDK, and it's automatically activated in most of the JDK distributions. So you don't have to do anything in addition to use CDS, the default CDS. If you are curious, the CDS locations, of course, they vary depending on the platform. If you use a Linux-based distribution or a Windows-based distribution, the path is different. Nevertheless, it's there. If you use an older, basically, JDK, you have to create this manually. This is about CDS. Of course, it was enhanced because initially, as mentioned, it was part of the Sun 1.5, and it had some limitation. It worked only with C1 compiler and in serial GC back then. In JDK 9, it was slightly enhanced to support server or C2 compiler and other collectors and so forth. What is a bit more interesting, because we don't have only, or our applications don't have only core classes, right? The JDK core classes. We have a lot of other classes in our class path. The feature which came with JDK 13, it's called App CDS. This extends basically the concept of CDS. So in the archive itself, there are also classes loaded by the application class loader, but also custom class loaders. And this is actually a big gain, or the thing started to be more interesting, I would say, because suddenly you can include in the archive more and more classes. The thing is, don't look at this archive as being just like you package your bytecode in the jar. No, it has a different representation basically, and the representation itself, the format itself, the footprint is few times larger than a normal jar. If you want to get a grasp on it, I measure it here. So basically, for 3,959 classes, the footprint of that archive was about 22 megabytes. So it's not negligible, if you ask me. And that's why if you have a big class path with a lot of dependencies, don't expect this archive to be quite small. One of the inconvenience, I would say, with App CDS, it was that it's 3 steps creation. Basically, to create an app CDS, you have first to start the JVM, to dump a class list, then in the subsequent or on the second step, you have basically to use the class list to create the archive, and in the third step, you have to use the archive. So this was not very convenient. That's why dynamic CDS basically simplified a bit this process in the sense that you create the dynamic archive only in 2 steps, basically. First step, you start the JVM with a command line. I will show you, I will demo these things quite soon. So first you start the JVM, you create the archive, and in the second run, you just use the archive basically, and that's it. One important aspect about dynamic CDS was that it has a slightly different approach than app CDS, in the sense that I will switch the slide and you can check the diagram on top. Basically, the app CDS if you create an app CDS, basically it also contains the system classes. If you create a dynamic CDS, it's a slightly different approach. It has a layering approach. Basically, the dynamic CDS refers a base layer archive, which could be the default one, which is basically included in the JDK, as mentioned, since 12 version. Or basically, you can also chain an app CDS as a base layer archive. So it's slightly flexible, the mechanism. You might ask yourself when I would probably use this flexibility. Well, an example is, for example, you have your base layer archive, you create an app CDS with the common ground, for example, the framework stuff, and then on top you create the dynamic CDS contains only the flavors, basically. And this is the difference. You will also find it under the name as dynamic, and the other one, app CDS, with the name of static, basically. This is just namings for historical reason. It doesn't matter. You can also chain these archives, for example, dynamic and static. You can chain them as it is written here. And the separator between these differs. If you are on Linux, it's a column. If you are on Windows, it's backslash and semicolon. These are just details, but it doesn't really matter. The thing is, HotSpot at the moment supports only 2. Basically, you cannot chain 3 of them. And it's always static or dynamic if you want to use both. Or if you when you create a dynamic archive, you rely on the app CDS archive, you can just specify the dynamic archive. And that's basically it about it. Few milestones, some of them are already I was already mentioning them. It's CDS is there since 1.5. Of course, there were a lot of basically enhancements. App CDS, I didn't mention this. Initially, it was part of a commercial feature, I think in JRocket, and then it was backported to OpenJDK since 10. And then in 12, basically, I already mentioned the CDS archive are created during the build time, and then in 13, things started to be a bit more interesting and easier from developers, because you create this dynamic with less effort, basically, and so on and so forth. One important aspect to mention is about lambdas, because in our frameworks today we're using a lot of lambdas. And the lambda, basically, when the JVM starts, the class is generated on the fly, is generating when the class starts. And initially, these classes generated, which are based on the lambda expressions, were not included in the archive. The things were improved. If you see here in 15 and 16, these are included. So if you are using the latest LTS 17, you also take advantage of these lambda classes. And recently in 18, there was another interesting feature. The problem with app CDS and CDS or dynamic CDS was that if you create the archive with one specific JDK distribution, you cannot use with a newer JDK distribution. For example, if you create it with 16, you cannot use it with 17. It's not like bytecode. And these things changes starting 18 in the sense that you can you can upgrade, for example, the JDK and use a previously created archive. So things are getting more and more interesting. In a nutshell, the latest JDK you use, the better. Well, this is not always possible or easily possible in practice. Nevertheless, you have to understand these things. Yeah, here it's a bit more in depth about the CDS structure. This is a HotSpot representation, of course. Basically, the CDS archive is split in multiple regions. In total, there are 7 regions in HotSpot. Only 5 of them are actually used. 2 of them might be empty sometimes. And of course, each has its own particular, let's say, purpose. For example, 3 regions pertain to metaspace, 4 regions pertain to the Java heap, as you see in the diagram. And each, as mentioned, for example, in metaspace, you can have vtables, you can have symbol table, you can have, for example, string table, all of those internal things that we basically don't care too much. And in the Java heap, just an example, in the CA0, for example, in the closed archive region, they are stored intern strings, because also intern strings are part of this archive. With AppCDS, this is very nice. With dynamic CDS, with AppCDS, there was an additional step. It was a bit cumbersome to include intern string in the archive itself, but with dynamic CDS, basically the things started to be easier. So in a nutshell, this is the internal structure if you're just curious about details. But from a developer perspective or from the user perspective, the bottom part of this slide, it's basically important. It says that when this archive is created implicitly during the dumping process, it's mapped to a fixed address, and you have this address here. And the problem is because ASLR, basically this is a security patch enhancement, which says every time inside one process that the virtual space, it's randomized. So it's not always, for example, the heap starts on a different based address inside the process and so on. And this slightly changes and might impact the concept itself, because the archive, it's always mapped at the fixed address. On testing environments, you can disable it, but on production, I wouldn't recommend. But for testing purposes and for playing with it, to make sure it's properly mapped, you disable it. If you don't like this address at all, you can choose a different one, because HotSpot itself has a flag to specify that one share-based address. You can specify it. Or if you say, well, I don't know, I leverage the OS, there is also the possibility you set it to 0, and then it's mapped to an OS selected address, base address. So basically, this is what you should consider when you play with the archives themselves. And to inspect, basically, to read all these regions. Here I included a snapshot. So when you create this archive, basically the dynamic archive, if you start with this -log: CDS, it's very, very handy, and I recommend you in all your testing purposes to use this to make sure the archive is properly created and mapped, because otherwise it's not very obvious. So you might think, oh, I'm using CDS, but probably there are some issues. So always doing tests, use this flag. And here you can see the regions that I was mentioning about, because I didn't change the share-based address. It's implicitly mapped at the one defaulted by the hotspot. Okay, so that was like a slight introduction. Of course, there are a lot of things to mention. I also wrote an article here on my website, and this is more in depth, but in the presentation time, I cannot cover a lot of points, just to give you the surface. And here I'd like to demo this. I'd like to demo in essence the dynamic CDS in HotSpot to get a grasp, to get a feeling how it works and how much speed you can gain. And for this, what I will do basically, So here I'll follow this guideline that I've created on GitHub. You can easily find it. I also tweet it after the session. I will use the Pet Clinic project because it's the one of the most. It doesn't matter basically. You can use whatever project you use as long as it's a JVM based. It doesn't really matter. So I'm using this one as a black box, so I don't do any code changes at all. That's the beauty of this CDS. So it's you customize from external. You don't change the code. So I'm using the Pet Clinic. I have the project already downloaded. So I'm going to basically go inside the Pet Clinic. Let's choose JDK, maybe 18, OpenJDK 18, why not? It's the last one. And now, so I'm inside the project, and let's move here to the dynamic CDS. By the way, here are a lot of other things, how you can create the app CDS and so forth, but I will focus only on the dynamic CDS today. I would like to build the project itself. By the way, I think the font is sufficiently big for the audience, right? Yeah. So I'm building the project, of course, with I don't care about tests in this phase. I want to be as fast as possible. And then maybe this is a bit too small. So to create the dynamic CDS archive, the first step is basically to create to start to launch the JVM with this flag. Archive class is at exit. Server port, it's 8080 by default. It's not really necessary, but I will just put it here. And this is the thing. The one aspect you have to take into account when you create the archives, the dynamic CDS archive. Basically, you can create it in two phases. One, when, for example, the JVM successfully stops, so not when you kill the JVM, or during the runtime with GMDC. And the problem is, I will create the archive when the JVM successfully stops. The thing is, because some of the classes are lazily loaded, it's recommended actually to open your application and use it a bit. So don't just start the JVM and stop the JVM, because you might basically avoid some of the classes which will be lazy loaded. And this is what I'm doing at the moment. So this is my Pet Clinic, sorry. So I'm trying to browse a bit in order to warm a bit, relying on the fact that more classes will be loaded. So I just playing around, it doesn't really matter. My intention is to use as many endpoints as possible from this application. Now I'm adding a pet, doesn't matter, to 2022. So then I add a visit, my visit, and I think I'm done here. Maybe I also add the owner, George, Franklin, Krakow, phone number 123456. Maybe, yeah. Veterinarians, this is just for browsing. I don't have any errors. Okay, so basically what I did, I started the application telling, yeah, I have some errors, but it doesn't matter. What I did basically, I just started the application telling the JVM to create basically the archive at the end. And because I want more classes to be loaded, I also used the BD application. And here, if you check now, the archive itself, it was this one. So it was created, it's around 70-ish megabytes. And the name of this is dynamic-cda. So this is basically the dynamic archive that I've created, and this is the first step, because I mentioned there are two steps. The second step, so after you create it, you start the JVM, you warm it up, you use it a bit, and then you just create it. Then you have to use it, and to use it, it's actually simple. This time you just start the JVM and say, hey, just use this JCA. This is the JCA is the dynamic archive. And of course it starts. and doesn't load anymore the classes using the normal process, just reads the CDS archive and maps it. And here you can see it's slightly better. Spin backlink application 4.242 seconds. But honestly, I don't rely on these Spring Boot timings, because the problem is if you do your performance test, if you rely on these timings without proper measurements, you might be foolish, because Spring has a lot of beans lazy loaded. So the moment when this basically message is printed, it doesn't mean the application is really ready to fulfill your request. And for that, what I've did, I'm showing to you here a simple shell script actually. This measures the time since I'm starting a process until it responds successfully with the 200 HTTP code to some API call. And I just use here owners find. This is the API call. And this is how I measure this. So I don't rely on the message provided by the Spring. And for this, now I have to compare both scenarios. So how fast, what is the gain with this actually dynamic CDS and no dynamic CDS. And the first scenario is I will start, actually you can start more instances, it doesn't matter. I will start in this presentation only 2 instances. So I'll measure the time until the application starts and it's ready to fulfill the request. So this was 6.9 milliseconds. And the second case, I'll start another one on a different port. Let's see, it should be around 6.7 seconds. Yeah, so something there. And now, so this is the default case. And now with my dynamic CDS archive already created, I will, so look here, I specified the dynamic CDS archive, and let's see how much I benefit of this. Yeah, so it's slightly better. It's not significantly better, but it's slightly better. Yeah, so basically in the default use case you have 6 dot something. With dynamic CDS you decrease, or you are a bit better, around 1 second. Well, if it is enough for you, I cannot say. It really depends on your use case, but at least you will see a benefit. And of course, it really much depends on your class path, on your footprint of your applications, and so on. So you have to test it on your side to decide if it is really benefit for or not. And here I summarized this. So for me, at least, it was 1 second in this particular case. On average, it could be up to 30% reduction. So 20, 30, I would say it's quite a lot, because you don't change at all the code. You just play with the JVM settings. This is the summary. I already mentioned all of this. The thing is, I was not focused on the constraints. The constraints are very important because the problem is when the CDS archive, this I already mentioned, just to remind you, when you create a CDS archive, you cannot use a different JDK unless you start with 18, because if you create with an older JDK, the archive, and if you run it with a newer one, it doesn't work. More than that, CDS archives are not cross-platform reusable, so it's a different story. It's not like the bytecode. If you create it on Linux, it should work. It will run only on Linux. The most important thing is, if you create the archive and you regenerate the jars, even if you don't change the content of the jars, the CDS is disabled. So basically the top layer is disabled. So be very careful, which means basically the moment when you create the dynamic CDS archive, you keep the same jars. You don't regenerate the jars, because otherwise it won't work. It's just disabled. And there is another subtle difference or reminder. When you create the CDS archive, you have one class path. When you run it, if you change the class path, or if it is not a prefix of the class path that you run it, it still doesn't work. So these are basically some corner cases you should be very aware, because otherwise you might think, okay, I'm creating the CDS, I'm regenerating the jars, and then bam, if you run it, it won't work. Because it's, so you, in a nutshell, you have to be very conservative by keeping the same jars and the same class path, at least as a prefix, for the moment when you create the CDS, when you run it. And of course, there are other basically limitations. If you have a jar which refers another jar as a class path attribute, those are not included. Some classes are, as you already saw in the listing, some classes could not be included in the CDS archive and so on. So this is all in all about dynamic CDS, how you can use it and how much benefit you can gain out of it. I try to demo it quickly. Now let's move on and see how the things are in OpenJ9. Basically, OpenJ9, as mentioned initially, it's a different JVM implementation. It has nothing to do in common with HotSpot, right? So it's totally different. And a similar feature, it's there since a while, since SDK, IBM SDK for Java 6. Which was introduced in 2007. Of course, it was enhanced. Every feature is enhanced by time. The main difference, so the idea is the same. I'm just dumping some classes in archive, and on the subsequent runs, I'm reusing them. The main difference with OpenJ9 is that it also includes AOT, which is not anymore possible in HotSpot. What is AOT? Basically, when you start the JVM, it dynamically compiles the code, and that dynamically compiled code, or native code, it's also stored in this archive, which is slightly different than the HotSpot approach. HotSpot stores only classes or some parts of the heap, as you saw. But in OpenJ9, it covers also the native code. There is a quick, I would say, quick reminder or a short limitation in the sense that with this JVM implementation, if the custom class loader, doesn't extend the URL class loader, as it here, you have to use some helper APIs in order to basically tell the JVM, hey, I want also these classes to be part of the archive. Otherwise, they are not part. But the beauty with the SCC, is that it's a bit easier to create it, and it's a bit more flexible than HotSpot. So you don't have to run the JVM twice. You just start it once, and if you start it during the execution, if one class is not part of the cache, is just add it, and that's it. It's much simpler, in my opinion. Well, structure is, of course, is different, because also the way OpenJ9 deals with the internal representation of the classes is different. Basically, in OpenJ9, a class, it's split into parts, a mutable part and the immutable part. A ROM class, it's the one which is basically stored in the archive, and it's shared between multiple JVMs. So this is the immutable part, and it contains pointers to, for example, superclasses, interfaces, inner classes. So it's just a part of it. The other part, which is so-called, this is the OpenJ9 terminology, RAM class contains all the other things, and this is local. So inside each OpenJ9 JVM instance, you have these RAM classes. Nevertheless, the ROM classes are basically shared across all of these. As you can see here in the structure, it contains also the profiling data. Of course, there are some counters and so on. But as you see, it's a slightly different structure, and you can also check this structure easily if you launch the JVM and if you profile the archive. It basically tells you all the regions and how big is each region and so on. So this is about OpenJ9. Now I will try to get back to my demo, and I will try to test how much or how long does it take. So in order to do that, I'll switch back to my guideline from here. And in the guideline, I'll access the second link, which is SCC. And here, it's the same project, but this time make sure you have the Semero runtime. Otherwise, of course, doesn't make sense to discuss about this feature. So I'm using at this moment, I'm using Semero, the OpenJ9, and I'll enabling. So as you can see here, it's Eclipse OpenJ9 18. And now, just to make sure, this is not really necessary, but I'm rebuilding again the jars just for the tests consistency. And meanwhile, I'll try to explain. So in order to start the OpenJ9 and to tell the JVM I want to enable SCC, you have to specify Xshare classes. This is the parameter. Of course, there are some flags. For example, you specify the name, you specify the directory, some soft, some hard limit, and so on. Here I'm a bit cheating because I tell to the just-in-time compiler I want quick start. Quick start means basically it's optimized for faster startup, and this is a flag particular to OpenJ9, but all the other parameters are basically the same. So I'm just copying this. Okay, this was built, and I'm trying to launch it. So I'm launching it now, and yeah, of course, I should do the same thing. I should go here, and then I should browse a bit the application. I know what it happened. I didn't close the previous process. Now it should be good. I'm launching it again. Okay, so it started. Now I'm switching back to the Spring Pack Clinic, and I'm doing the same repetitive stuff, relying on the fact that some classes are lazily loaded, and so on and so on. Doesn't matter. Add the path, add the visit, my visit. The beauty is that I have all of this already in the cache, so I'll add an owner, Martin, Musterman, Krakow, phone number, okay, vegetarians, and so on. Okay, so basically now I created, I still have some issues like always. Okay, I think I have to ignore this. Anyway, so if I list all the content, you can see basically this is the archive created. So remember the name SCC as I specified basically here, SCC. And yes, I specified also some hard limits. How you know to specify these limits? Basically, you have to do multiple trial runs. This is what I did, and I ended up this. It's a good hard limit, so 256 megabytes. It's a good starting limit. But when you test and you create this, you have to do multiple trial runs and basically inspect the content of the SCC archive, and you decide, okay, this would be a good hard limit for my class path for my application. Okay, so I have this created, and now let's see basically how long does it take to respond. I'm stopping it. So again, I'll start the JVM, and I will measure the first time to response on port 8080, and now let's see how fast it is. So it's 4.5-ish. So remember the previous, how much it was? It was 6 point something with dynamic. In OpenJ9 it's 4 dot something. So I would say it's not, it's quite something. And if I start a second instance, measure it again, just to yeah. So it's more or less 4 dot something, which to be honest is something, because I didn't change the code at all. I'm just switching the JDK distributions, and I'm just playing with some settings, and that was it. These are also some tests that I did ahead before when I prepared the slides. In a nutshell, this is a kindly interesting feature. And yeah, in comparison to the dynamic hotspot, of course, is not apples to apples, because it also, this is combined with AOT, and you cannot beat AOT. Yeah, but anyway, I think it's something that you should consider if you are keen on these startup times. And the last but not least, AOT. So if nothing is interesting for you, so you say, okay, dynamic is not good, it's not enough, then I change to OpenJ9, I test it with this, it's not, yeah, it's not something that I should benefit of. Maybe try Crack, or then switch to AOT, because if you are really keen on raw startup timings, nothing can beat AOT. Right, so that's no doubt about it. Of course, AOT has other runtime limitation in comparison with, for example, just-in-time, in the sense that some of the optimizations in some cases are not so powerful as just-in-time compiler. But nevertheless, talking from a startup perspective, you will get the fastest response. Here, the option for using this, it's Graal VM native image. So basically, with Graal VM native image, you just take the bytecode, and this is the beauty of the native image, because during the build process, there is a phase where, for example, the application is configured and initialized, and parts of it are run at runtime until they reach a fixed point. And this process is repeating until all the paths are discovered. So everything which is reachable, it's compiled, it's AOT compiled. And at the end, basically, you end up with an executable, like you do with C++ or C or whatever. So it runs on an executable. This process, it's very interesting, and it's something which, if you're keen on this, read the paper. You can easily find it, but it's something new, and it's something very interesting how it is doing. All in all, so if you want to compile this with Graal VM native image, you have this option. And now I'm switching back to my actually guideline, and here I will choose AOT with Graal VM native image, and this is a big question or exclamation mark. If you have your project which runs for years and it's a monster, you have a lot of code, AOT, if you try to compile it with AOT, I really doubt you'll be able to. The problem is with AOT, you have to be prepared. You have to use some specific extensions, for example, if you are using a framework like Quarkus or Spring or whatever, because otherwise you'll face a lot of issues, and I really doubt you will be able to easily port it and to easily compile it to AOT. That's why in this scenario, I will use Spring native extensions and not the classical Spring anymore, because you can do that, but as mentioned, there are either a lot of on-top customizations and configurations that you deal with, and maybe at some point you face limitations. So that's why I'm using the Spring native, which is analogous to the Spring project that I used before, but this is meant to be AOT compiled. So this is a very important remark, and here I'm switching. Okay, so I'm switching to the other project, so Spring Native. I'm cheating a bit in the sense, not cheating, but just to be a bit more efficient. I won't build it at the moment, because if I have to build it, it will take few minutes in a row. So probably 10, 12, 13 minutes. So that's why I have it built already, so I don't have to wait. But usually, of course, you have to build it. So it's build.sh. This file comes with the project itself. And I have it already built, so I'm just running it. This is the thing. So to run it, the thing is, after you build it, it creates this native executable path-cleaning.jpa. So if you can spot it already, I'm using the JPA implementation for the path cleaning, which before I didn't use, but it doesn't matter. Just for you to have a clue how fast it is, the JPA doesn't play a big role into this test case. So if I try to run it, you see it's less than 1 second. Actually, it's quite fast, and it's obvious like that because this is actually a native, an executable application in comparison with the other one, which basically it's bytecode plus some sort of caching, which contain some metadata, some parts of the heap, or in case of OpenJ9, some already dynamically generated IoT code. But in this case, everything it's actually IoT compiled. And that's why I was mentioning nothing can, if you are really keen on improving the startup performance for this type of applications that I'm mentioning before, like serverless, short-lived, and if you really want faster startup times, think about this approach. Nevertheless, you have to understand that it's not quite, at the moment there are limitations, in the sense that you already get a clue, you have to use a framework with these extensions. If you are using third-party or transitive dependencies, they might not be prepared for IoT. What means to be prepared for IoT? Well, there's a lot of limitations listed on the Graal native image. This is their public web page, and basically there are limitations in the sense that some features are not yet supported. For example, invoke dynamic. The problem is, or not the problem, the rationale is when you compile IoT, it's a closed word optimization. So basically, it compiles only what is seen during the runtime. So things that are not seen during the runtime, of course, are not compiled. And this is the case, for example, if you use reflection or dynamic class loading, you need additional configuration to tell the JVM, hey, also include this in the compilation process, because this is not easily deductible during the build time. Or there are some other features that might operate differently, like signal handlers and so on and so on, in the native image, I mean, in comparison to the traditional one. So all in all, that was basically it. I have quite a lot of resources for this talk. So the article that I mentioned, I explained quite in depth app and dynamic CDS from HotSpot. You have these faster JVM startup techniques from GitHub, where you can just copy paste the command lines and try it with your project. Of course, I also had to look inside the OpenJDK sources, OpenJ9 sources, especially for the structures and so on and so forth. Okay, that was all. I think now it's the moment to look at the questions. Let's refresh. Okay. So are NCDS optimizations enabled by default when you use newer Java versions, or do we need to spend some effort to benefit? If you mean just the CDS archive, if you mean just the default CDS archive, which comes implicitly when you install the JDK, since 12, it's there. But app CDS and dynamic CDS, this is manual work. So if you refer to just CDS, which is called the default archive, is there. But if you mean the static or the dynamic archive, app CDS or dynamic CDS, no, you have to spend additional effort. I think I was clear. How do you apply CDS with CI/CD when you aren't used? Yeah, this is a very good question. How do you apply CDS with CI/CD? The problem with CDS when you use the CI/CD, usually when you use CI/CD, you have a slightly different class, but you run also the tests. The way how I did it was that you need to, if you are using Docker containers, you need to pre-warm or pre-package a Docker container with the CDS archive itself. So basically, I used multi-stage build with 2 phases with Docker containers. And in the build process, I also injected the CDS archive. So basically, during when I ran it, for example, in what environment, development, SIT, UAT, I just took the pre-packaged Docker container with the CDS archive and then I use it. This is probably the way to do it, because otherwise, it's not quite easy. I know there is also plugin for Maven, but to be honest, I didn't try it. What I tried was with this pre-warm Docker container image, which includes already the CDS archive. You can do it also by using volumes with Docker, which means using volumes, it's like sharing. But the problem with sharing is, well, if you go in production and you use these volumes, maybe it's not a good security idea. So I think the best way is to include it in the Docker container. How you tested that application with higher compile time? Have you tested that on applications with higher compile time, 5 minutes? You mean, I think the compilation time doesn't matter. It matters, I mean, of course, if the compilation time is longer, you probably have a quite significant class path. The answer is no. For example, in my production applications, I'm using microservices and they compile less than 1 minute, actually. But I also don't see the link between compilation time and the startup time, because, yeah. Can one easily view the contents of JS? Not really, basically. If you want to see the content of an archive itself, you cannot see the content. You can see just some addresses and the regions and the addresses where those regions starts, plus the offsets. But if you think of it like, I don't know, like a heap dump, no, there is not a similar thing. Is it safe to use caches like Caffeine? Yes, why not? Use caches, and maybe using caches like Caffeine with CDS, it's good because you can also think of it like you have the app CDS as a base layer with the framework, and on top only the features, the flavors from the application, like this Caffeine basically as a dynamic archive. So basically, yeah, why not? It doesn't matter actually the dependencies that we are using. What is important is to make sure you preserve the class path during creation versus during the normal run, and to not regenerate the jars. Okay, I think I lost a bit the number. How to deal with those optimizations in Kubernetes environments that you run? I cannot answer this question because I don't have enough experience in Kubernetes environments. Sorry for this. What is this tool which you had selected? This tool. No, this tool, it's a foolish shell script that I use. So the question is, what is this tool which you had selected different JDK versions? It's just a shell script created by myself, and I set it in my bash profile like an alias with the alias JDK export. And when I type JDK and export the shell, my custom shell starts and it expects something to type in. I can send this version to you. If you send me an email, I can send this, but it's easy peasy to do it. Another one, you said this is benefit for serverless application, but I'm not sure you are able to tweak JVM there. Not experienced. Any comments? Yes, basically we are doing a lot of serverless. We have a lot of landavs, because the thing is you need to be as cost efficient as possible. And with serverless, we try to compile natively, to be honest. So we try to use native image, Graal native image for that. And we are trying to publish the binaries and run it as a native code, because otherwise you have to start a bit, and at least in AWS you pay for this, and it's also time limited. So for serverless, it's either you go directly with native, either Quarkus has a very nice feature. You can do an application to start it either as a Lambda, either as a microservice, and then if you are using reactive extensions, you can again compile it natively. Sorry, I think the time is anyway over. I'm here, so come to me to answer the questions. Thank you so much.